Algebra 2, Unit 3, Lesson 3, Part 2. So this lesson is going to cover two topics having to do with the quadratic formula. One is using the discriminant to determine solution types, which is a common question that you might be asked on tests, as well as a useful skill when it comes to choosing a strategy for solving quadratics. And then how to answer multiple choice questions involving the quadratic formula. So, all right, so without further ado, let's take a look at this. Now, types of solutions for quadratic equations. We're going to look at each of these in detail on the following slides. So if you're following along with the notes, which I have here in their like original form, so you might have them, you might not if you're watching from home, but you don't have to write them down now. So we're going to look at each of them in detail. So you could have two real rational answers. And before we jump like too far ahead with that, I do want to talk about what the word rational means, so that those notes won't necessarily help you too much if you don't know what the word means. So like, big deal. Two real rational answers. Great. So rational numbers, in the word rational, you'll see the word ratio, which might help you. A ratio is a fraction. A rational number is a number that can be written as a fraction. Okay, so it doesn't mean it has to be written as a fraction. It just means that it could be written as a fraction. So obviously something like 1/2 is a rational number because it is written as a fraction, but like 0.3333333 repeating is also rational because you could write it as 1/3. And then a number like 4 is rational because you could write the number 4 as 4/1. Now, we don't usually write it as 4/1, but you could. So a rational number is a number that can be written as a fraction. So when you're talking about two real rational answers, real means it is on the number line, okay? And not only is it on the number line, but it would correspond to something that could be written as a fraction on the number line. One real rational answer, okay? So you could have one real one, and it would be rational. So you could have two, you could have one. You could have two real irrational answers, okay? And just to break that down, the prefix IR means not, okay? So it is a negation. So you have rational and irrational, regular and irregular. So it's an indication that you have an opposite there. So rational numbers can be written as a fraction. Irrational numbers cannot be written as a fraction. No matter how you try, those numbers cannot be written as a fraction. And then the fourth type is two complex or imaginary answers. So if you get like a imaginary one, that would be like the ones that we were doing a couple classes ago, where you have just like 4i and 5i, or like plus or minus 4i or plus or minus 5i. Complex means there would also be a real component, so it would be like 2 plus 3i and 2 minus 3i, something like that. Okay, and those we've seen that we could get from like the square roots. So those are the four types of solutions that you could get. So now we're going to look at each type in detail. And in class, what I'm going to do is we're going to stop everything and I'm going to give you guys about 5 minutes to solve this with the quadratic formula, because we need practice using that quadratic formula. So we're just going to hold everything up. Okay, I'm going to let you guys solve it with the quadratic formula, and then we'll talk about these things that you could observe with it. So pause the video right now, pause it for as long as you need to pause it, and find the solution using the quadratic formula. And then look at those two questions. What kind of number is b squared minus 4ac? And is this equation solvable by factoring? So take a moment, pause the video, and try to work that out. Alrighty, so hopefully you did pause it. So working this out, I should time how long it takes me to do it just to make sure my expectations are realistic. So we have A is equal to 1, B is equal to -7, and C is equal to -30. All right, that looks like fun. The quadratic formula is the opposite of B plus or minus the square root of B squared minus 4AC all over 2A. So going ahead and plugging that in. The opposite of B, well, B is -7, and the opposite of -7 would be +7. And then this would be -7 squared minus 4 times 1 times -30, ouch, all over 2 times 1. Okay, let's see if we can do some work on that. Lovely. That is going to be 49 plus 120, which is 169. And 2 times 1 is just 2. And then the square root of 169 is 13. And then we would have to do this in pieces. So we would have x could be equal to 7 plus 13 over 2, or 7 minus 13 over 2. So 7 plus 13 is 20, and 20 over 2 is 10. And 7 minus 13 is -6, and -6 over 2 is -3. Okay, now a couple things, like let's take a look at that, other than like, oh wow. Okay, so first thing is let's confirm the answer types. So I have 2 answers. There they are, 10 and -3. They are real numbers. There's no I involved in that. And they are rational. Both of those could be written as fractions. So you could write them, well, there they are. Like you can see them written as fractions. So 20 over 2 is a fraction. Doesn't, like, I mean, you could have said 10 over 1, but just means able to be written as a fraction. There it is. -6 over 2 is a fraction, okay? So we can confirm that those are 2 real rational answers. Now, let's come over here. What kind of number is B squared minus 4AC? So in this case, the B squared minus 4AC was 169. And what I want you to note about that is that that is, one, it is positive, and it is also a perfect square. Okay, and you might have put other things down on your list as like what it was, but those are the things that you do want to note, that it's positive and it's perfect square. Now, what makes that important is that when you take the square root of the 169, you get a rational number out, okay? And basically the square root goes away, so your final answer does not have a square root in it. And then the next question there is this equation factorable? Okay, so could we have solved this by factoring it? Well, we've got x squared minus 7x minus 30. And I believe that does factor into x minus 10 and x plus 3. And so, yes, that is solvable by factoring. So we could have factored it. And you can kind of see why factoring is a preferable strategy. This is a lot of mess, a lot of work, and a lot of potential errors. This is much less work, and once you get here, much less likely. But you would have to set up your area model or whatever strategy that you're using. So that took me 5 minutes for the whole thing, including the reflection questions. So hopefully 5 minutes will be a reasonable amount of time for you guys. Okay, next one is one real rational answer, and we are going to take a look at that one. So as with the previous problem, go ahead, pause the video for about 5 minutes, however long you need to pause it, and work it out, and then look at the kind of number you have, and you can use the previous slides to give you an idea of what we would be looking for there, and then is this equation solvable by factoring? Okay, let's take a look at this. So in this problem, A is equal to 4, B is equal to -4, and C is equal to 1. Our quadratic formula is the opposite of B plus or minus the square root of B squared minus 4AC all over 2A. All right, let's go plug that in. The opposite of B is -4, so the opposite of -4 is +4. And then we have -4 squared minus 4 times 1 times 4. I did that in the wrong order, but it doesn't matter. You do 4 times 4 times 1 all over 2 times 4. Okay, so what do we have going on in here? We have 16 minus 16. That is 0. Over 8. And the square root of 0 is 0. So essentially, yeah, if you add 0 and you subtract 0, that's exactly the same thing. So we're left with 4 over 8, which simplifies to 1 over 2. So let's confirm this. I have one answer, 1/2. The one answer came because plussing and minusing were exactly the same thing. Okay, so plus and minus gave us exactly the same thing. My answer is real, meaning I can find it on the number line, and it is rational, meaning I can write it as a fraction. So what kind of number was the b squared minus 4ac? Well, in this case, it was 0. And then the question here is this equation solvable by factoring? So could we have factored that instead? And you might want to bust out your area model to do this, but it does factor into 2x minus 1 times 2x minus 1. So yes, that is solvable by factoring. Okay, third problem. This one is 2 real irrational answers. I think we've looked at this problem before, so if you take really good notes, it is possible you could find this or some other piece of it, I don't know, in your notes somewhere. But go ahead and pause the video and solve this equation using the quadratic formula. And then again, we're looking for those observations. What kind of a number is b squared minus 4ac? And is this equation solvable by factoring? All right, so we have a is equal to 1, b is equal to -2, and c is equal to -5. Quadratic formula is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Notice I keep writing it, I keep saying it, okay? That is just that repetition. Repetition helps you memorize stuff. So if you want to make sure that you have the quadratic formula down, you're not going to forget it, you're not going to misremember it, then this is what you need to do. You need to write it, you need to say it, you need to repeat it, see it, and keep using it. So the opposite of b in this problem is -2, so the opposite of -2 is +2. Underneath here, we're going to have -2 all squared minus 4 times 1 times -5 all over 2 times 1. And let's see, what do we have there? We have 4 plus 20, which would be 24 over 2. And I believe we did this one in the last lesson, and I said you could leave it right there. yeah, you could leave it right there. The only thing, like there's a couple of things that you could do with this, and I still haven't decided exactly how far until we get to the simplifying the square roots part. But you could simplify this further. Just anyway, what it would look like, you know what, not gonna bother. You could leave it right there. Okay. So what kind of number is the b squared minus 4ac? Well, in this problem, it is positive, but it is not a perfect square, meaning that when you take the square root, you're going to get some awful decimal. You could also go through this process where you simplify it, okay? And you would end up with, you would still end up with a square root in your answer, okay? So yeah, pretty much can't take the square root. And then, is this equation solvable by factoring? Let's try it. So we set up our area model, and we put in the -5, and we're looking for two factors of 5 that'll add up to 2. There are none. Okay, and so the answer to that is no. And I did want to point out that this is irrational when you go to take the square root of the 24. It's going to give you some hideous number that you cannot write as a fraction. So it'll give you an irrational number there. And problem type number 4. 2 real complex answers. So this problem is almost the same as the one that we just did, except we have a +5 instead of a -5. I was timing something. I've been doing work for almost, well, it's been well over 2 hours. So that was my timer to remind myself to get up and move a little bit. But I'm not going to stop in the middle of the video. So like it'll just have to wait. But go ahead, pause the video and work this one out. Again, making certain that you are observing the things that you need to observe. All right, so in this one, we have a is equal to 1, b is equal to -2, and c this time is +5. The quadratic formula is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And now we're just going to throw those numbers in. The opposite of -2 is 2. And then we're going to do -2 squared minus 4 times 1 times 5 all over 2 times 1. Now this time, that value of the b squared minus 4ac, we are going to have 4, because -2 squared is 4, minus 20. 4 minus 20 is -16. And then you might remember this, like -16 can be broken up into 16 times -1. The square root of 16 is 4. Square root of -1 is I. So that could be that, okay? Which could be simplified further into, let's see, 2 over 2 plus 4i over 2, or 2 over 2 minus 4i over 2. And let me erase this, there we go, for a second, and then we'll just, because I did 2 things at once there, so I want to make sure I explain it to you. I did 2 things. One is I split up the plus and the minus, okay? So we had the 2 plus and we have the 2 minus. So that's one of it. The other thing I did was I broke up the fraction, and that was me making kind of a spur of the moment decision on the best way to illustrate that. So if you have like, let's say, you know what, just that's what you do with the fractions, okay? If you need me to go back and explain how the fractions work, let me know, okay? And I'll do like a short, like 5-minute video on just the fractions. So, you know, you got the 2 over 2 and then the 4i over 2. 2 over 2 is 1, and then 4 over 2 is 2i, so that'd be 1 plus 2i, and then same on the bottom. And do note that you have 2 answers, okay? Two real complex answers. Oh my word. They're not real, they're complex. Now I'm second guessing something that was on an earlier slide. Anyway, two complex answers. So what do we want to notice about the b squared minus 4ac? What I want you to take away from that is that it was negative. And the moment you end up with a negative underneath your square root, you will end up with a complex answer of some sort, or an imaginary answer. It kind of depends on how the rest of the problem works out. But yeah, so you end up with an imaginary, you end up with an I in there somewhere, because the square root of a negative is always going to land you with an I. Is this equation solvable by factoring? Well, you could try the same thing, but it's going to be almost the same area model that we had before. So no, it was not. Okay, so let's go. I can't believe I wrote two real complex answers. Good grief. We'll make sure the handout's right. Okay, so let's look over here to the summary chart. So if all of that was a little bit much for you, and you're like, wait, we just did all that solving and I made these observations, we want to put this information into a form that's a little bit more user-friendly. So the discriminant, so we know what the discriminant is. The discriminant is the piece of the quadratic formula that is just called the b squared minus 4ac. So we just kind of home in on that one little piece of it. And the value of that discriminant can fall into four categories. It can be positive and also a perfect square. Okay, so that can be one of them. It could be, I think just to keep the order the same way, positive but not a perfect square. Okay, one of those you're going to get a nice square root. The other one you end up with a decimal. It could be 0, or it could be negative. So essentially, like, we've got the categories of, it could be positive, 0, or negative, but the positive breaks into two categories there, whether it is or is not a perfect square. In the first case, if you end up with a positive number that is a perfect square, you will get two real rational answers. Okay? And it will be factorable. So what sometimes people will do is they will just evaluate the discriminant and just to determine whether or not it's factorable. Okay, so they won't even finish the whole problem. They'll just do that one little piece of it. Once they know that it is factorable, then the preferred strategy is to go and factor it. But because not everything you can tell just by looking at it whether it's factorable. If you get a 0, then you have one real rational answer, and that is also factorable. If you have positive numbers but not a perfect square, what that means is that you're not going to be able to get rid of the square root. Okay, it just means you're not going to be able to get rid of it. And so you will have the two answers, same as for the other time it's positive. So positive results in two answers. And they will be real, but they will be irrational, meaning that you're going to have that square root stuck in there. And those are not factorable. And then the last one is, if you end up with a negative, you will have two complex. And the answer, I'm going to write it on my picture there, is no. No, it is not factorable. I don't know if you guys can see the no, but there's a no in that lower right-hand box. Okay, so there's like your summary chart, and it emphasizes the importance of the discriminant. So there are plenty of questions that can turn up on tests just that will ask you what type of answers will you get. And so these might be your 4 answer choices, and they'll give you a quadratic, and then you would have to know, okay, based off of what the discriminant is, what kind of answers am I getting there? And then for a practical, like, why would you need to know this other than to answer questions on a test? Because you'd hope that it have some use other than that. The other use is usually to determine if it is factorable. So should you take the time to try to find those number combinations or no? All right. Okay, so the second goal of this lesson was, how does this work with multiple choice questions? So hypothetical question, you're staring at your final, you're staring at the SAT, you're staring at whatever, okay? And it says solve that equation there, okay? So solve that equation, and there are your answer choices. So what I want you to do, and we will do this in class as well, is pause and take about 5 minutes, and I want you to go through those, go through what you know how to do, all right? And then choose which of those answer choices you would prefer. So take a moment, pause the video, and decide on your answer choice. Okay, so here are your options when you're encountering that. What we're doing here is we're looking at multiple choice questions, and how multiple choice questions, because of the nature of what they are, have the potential of other ways of arriving at the correct answer, okay? So one of your options is to solve the equation using the quadratic formula and match your answer. Okay, and that might be the best option for you. Okay, whether it's the best option for you depends on how good you are at using the quadratic formula. The better you are at using it, the more likely that's going to be the option that you want. The other option is to use Desmos to find the decimal equivalent and then match the decimal with the decimals generated with the answer choices, okay? Because the decimals, you're not going to get the whole decimal. In that particular problem, you could tell the answers were irrational because they still had that square root sitting in there. But that radical can be converted over to a decimal approximation, and you should be able to match them up. Okay, so this I'm going to assume we have already covered. So if you went and did the quadratic formula and you chose your answer choice, you already looked at option number 1. What we're going to focus on in the remaining part of this lesson is how would you leverage option number 2. So what I did was I replicated the problem. Hopefully I copied everything correctly. Okay, I replicated the problem. Okay, just having a moment there. All right, so let's go ahead and do this. I've got to turn that off. And okay, so here's how this is going to work. Hopefully I don't mess this up too much. I am going to start by graphing the equation in question. I think we're okay with that. Hang on. Yeah, okay. And I'm going to look at my x-intercepts. Okay. And now I'm going to click over here and turn on my pen, and I'm going to write those numbers down. Okay. So x is equal to negative 1.215, and the other answer looks like 0.549. Okay. The reason I wanted to write those down is because I'm going to need my Desmos for something else. Okay, so I write those 2 answers down, and what my goal now is to figure out which of my answer choices over here on the left correspond with the decimal equivalents of what I know to be the answer. So I'm going to delete that. You know what? I might have been able to leave it up. Let's look at leaving it up. Okay. All right. So what I'm going to do is start with answer choice number 1, and I am going to Yeah, I'm going to try to find the decimal equivalent. So when you're typing this, and this is why I feel like I should show you this and not just like say, oh, by the way, type it in decimals, okay? So we need to make sure we get it entered in exactly the way that it looks in the answer choice. If you're like, oh, it doesn't matter if my fraction bar is a little bit shorter. Yeah, it does matter. That's going to affect your order of operations. So what I'm going to do is start with parentheses, and I'm going to type in -2. Now I cannot add and subtract at exactly the same time. Okay. And so I'm just going to pick one. I'm going to pick addition. And then I need my square root symbol. And then I'm going to close that out. And now I'm going to type my division symbol. And the reason I needed to put the parentheses around it is because I needed that entire expression to go into the numerator. Okay, so notice this. Just I want you to really notice what happens here. I am getting a value. There we go. For x that is 0.215. Now that does not match the values that I have up there, which means that answer choice A is not the correct answer choice. Okay, so I am not going to pick answer choice A. Okay, not going to do it. Now, before we move on, I do want to take a moment and just show you what happens if you don't put that parenthesis around. So if you just type -2 plus the square root of 7, and then you do the division, okay? That is not the same thing. So if there's any question in your mind about whether or not you have a cat on your lap, whether or not those are the same thing, or does it matter how far my fraction bar goes? Yes, it matters. Those are not the same thing. All right, so now let's move on to answer choice B. So I've eliminated answer choice A, gave me something that wasn't there. So let's check out answer choice B. So I do need those parentheses. -1, I'm going to go ahead and do the plus sign. The square root of 7, and then divided by 3. And notice what I have here, okay? I have 0.5485. Well, that looks pretty good. The graph was showing me 5.49, but remember your rules of rounding. 5.485, that 5 is going to round the 8 up to a 9. So that's pretty promising. All right, that seems pretty promising to me that is going to work. Now, it's not enough that only one of them works, because you could have like one of them match but not the other one. So I do need to go back in and check the other one. And the easiest way to do that is just type in there and change that plus to a minus. And notice what we have here. We have negative 1.2152 and more stuff. And negative 2.15, 2.152. Yep. Okay. So both of them match. I feel pretty good about picking answer choice B as my answer. Now, what I would do, you do need to check both of them though, okay? It's not enough for one of them to match. Now, what I would do if I had the time, this is one of those things that you've got to watch a clock. Okay, if I got both of these to match, I feel pretty good about picking answer choice B, okay? I think it's very, very slim chance that there's other stuff in there. But just in case, I'm going to go and check the other one. So the next one would be plus, and then I would have a 2 out in front. That gives me 1.431. Okay, that one doesn't match. I don't need to check the minus. And for some reason, I made answer choices C and D the same. That was not supposed to happen. I think one of them was supposed to be a 6. Obviously, I'm on my game today. Good thing it doesn't affect the problem at all or what I'm trying to teach. Yikes. Good job, me. All right, so I think you see how that works. Now, it might be faster for you to just do the quadratic formula out than it is for you to graph it on Desmos and then type in the individual solutions to see if you can match the decimals, okay? That I'm going to leave up to you. If it's a multiple choice question, no one is checking how you arrived at your answer choice. They're only checking what your answer choice is. So don't photo math it. Okay, that is cheating, but using graphing and playing mix and match to leverage the problem type is not cheating. Just so you can see, like this, I have an obstruction here. Just like, I don't think he understands how a touchpad works. Okay. So the homework for this lesson is going to be available in OneNote. At the time that I'm recording this, I have not determined that. I'm actually recording this way in advance. So yeah, but check OneNote for your homework. Otherwise, that is the last lesson. So our last piece of the lesson. And let me know if you have questions.